Welcome to the world of AWS. Today, we explore AWS Virtual Private Cloud or VPC. AWS VPC is your private network in the AWS cloud. Think of it as your personal data center, but virtual. You have complete control over this space, providing excellent security and isolation. You can launch AWS resources here like EC2 compute instances. VPC is fundamental for building applications. Imagine building a house. First, you need your own plot of land. A VPC is like that plot of land in the cloud. You define its boundaries and build your cloud infrastructure on it. A VPC helps you organize resources logically and keeps them secure. You can create multiple VPCs for development, testing, and production. Now, how do you decide the size of your VPC network? This is where CIDR blocks come into play. CIDR stands for Classless Interdomain Routing, a method for defining an IP address range for your VPC. For example, you might choose a CIDR block like 10.0, 0.0/16. These IP addresses are private and only usable inside your VPC. The /16 part in the example 10.0, 0.0/16 shows the size of your network. A smaller number after the slash means more IP addresses. A /16 network provides over 65,000 IP addresses. Choose your VPC's CIDR block carefully to accommodate current and future needs. Ensure its IP range does not overlap with other networks you might connect to later. Your VPC is like a large piece of land in the cloud, which you can divide into smaller sections called subnets. Each subnet exists within a single availability zone, AZ. Using subnets in different AZs improves the resilience of your systems. Subnets help you organize resources effectively. Create public subnets for web servers needing internet access. Create private subnets for sensitive databases, away from direct internet exposure. Each subnet gets its own CIDR block, a smaller segment of your main VPC's CIDR block. Route tables manage network traffic. Every subnet must be associated with a route table containing rules called routes. Routes determine where network traffic from your subnet is directed. Think of a route table as a GPS for your network packets. Your VPC has a main route table by default. Each route specifies a destination IP range and a target for that traffic. The target could be an internet gateway for internet-bound traffic or local for traffic within the VPC. For example, a common route directs all internet traffic, 0.00.0/0, to the internet gateway. Control your network traffic flow by customizing route tables for your needs. This ensures efficient and secure traffic management. By default, your VPC is a private, isolated network. To access the internet, you need an internet gateway, IGW. An IGW connects your VPC to the internet like the main door of your virtual house. Attach it to your VPC and update your route tables. Add a route in your public subnet's route table pointing to the IGW for internet-bound traffic, 0.0.0/0. Resources in the public subnet need public IP addresses to use the IGW. The IGW handles network address translation for two-way internet traffic. For private subnets, use a NAT gateway. A NAT gateway allows instances in a private subnet to initiate outbound internet connections while blocking unsolicited inbound connections. Place the NAT gateway in a public subnet with an elastic IP address. Update the route table for your private subnet to direct internet-bound traffic to the NAT gateway. The NAT gateway forwards this traffic to the internet via the internet gateway. Your private instances remain secure without needing public IP addresses. Securing your resources, security groups and NACLs. Security groups are virtual firewalls for your cloud resources, protecting Amazon EC2 instances. They control inbound and outbound traffic at the instance level. Think of them as personal security guards for each server. Security groups are stateful, allowing return traffic if initiated from the instance. NACLs are firewalls for your subnets, controlling traffic at the subnet level. Think of NACLs as the main security checkpoint at the border of your subnet. Use both for a robust, layered security approach. Expanding and monitoring your network peering, flow logs, and beyond. Sometimes you might have multiple VPCs in your AWS environment. VPC peering allows you to connect these different VPCs privately and securely. Traffic between peered VPCs uses private IP addresses and does not travel over the public internet. It is like building a secure private bridge connecting your VPC networks. VPC peering simplifies your network architecture. Resources in peered VPCs can communicate as if they are in the same network. This is useful for sharing services or data within your organization. You can peer VPCs in the same or different AWS accounts and even across different AWS regions. Remember, VPC peering is not transitive. Direct peering connections are needed. To monitor network traffic in your VPC, use VPC flow logs. Flow logs capture detailed information about IP traffic to and from your VPC, subnets, or network interfaces. This log data can be published to Amazon CloudWatch logs or sent to Amazon S3 for storage and analysis. Flow logs are essential for troubleshooting network connectivity issues and security analysis. We have covered many important AWS VPC concepts today. A VPC is your private network in AWS. CIDR blocks define its IP address space. Subnets organize resources for availability. Route tables direct network traffic. Happy cloud computing.